Hello, everyone. Here is something that I hear a lot. Blind people don't play video games. Let me share something with you.
Hello, Unity developers, Unite conference attendees. I am Sightless Combat, award-winning accessibility consultant and gamer without sight, and accessible gaming officer for Royal National Institute of Blind People, the UK-based sight loss charity. I've had the fantastic opportunity to work on titles including but not limited to Sea of Thieves, Gears 5, Horizon Forbidden West, God of War Ragnarok, just to name a few. I want us all to be united on a shared piece of knowledge that with the right accessibility features, I and so many others, regardless of what level of sight we have, we can play video games.
Sightless Combat is not the only gamer with a disability. Here are a few other gamers with disabilities that you can find on YouTube, Twitch, X, and other social media channels.
Just as many assume that blind people don't play video games, developers often dismiss entire markets with "that nationality doesn't play games like mine." Both assumptions ignore untapped audiences wishing to engage with your content. The reality, accessibility, and localization, two frequently overlooked investments, can unlock significant new player bases and transform who experiences your game.
Hi, muy buenos días. Nice to meet you all. I'm Bianca, the lead developer of accessibility features in the Unity engine.
And I am Karl, the lead developer of the localization package. We are both part of the UI Toolkit team.
Today, we will both help you understand how you can reach new audiences with accessibility and localization in Unity 6. Many people with ADHD find it helpful when expectations are set from the beginning. Therefore, here is our agenda. We're going to start with a quick intro, where we'll talk a bit about what accessibility is, who it serves. Spoiler, it's not exactly what you might expect. And then we'll talk about localization and what are the main elements you should think of for localizing an app. Here's another spoiler. It's more than translating text. Then we get our hands dirty together by looking at a little game we have been working on. I will guide you through how we made it more accessible with Unity 6.
And I'll demonstrate how we built localization into the game from the ground up, covering everything from the text expansion challenges to cultural adaptation decisions that can make or break your international launch.
Let's start. Before we proceed with the tech side and the nitty-gritty, it is best to lay some groundwork. Who does accessibility serve? Accessibility is essential for people with disabilities, but it does help each of us. Here, I mean the disabled veteran who is missing an arm.
Me, when I was wearing glasses as a kid and would constantly lose them.
My friends after coming from a concert where they lost their voices singing.
Me, yet again, playing video games on mute while my kids are sleeping.
Literally most people that I know on early Monday mornings. And so many other temporary disabilities or situational limitations that we find ourselves in on the regular. Now, let's look at how accessibility features in games can accommodate the situations that we just spoke about. For those with motor impairments, control remapping can be a godsend, as this allows them to tailor the game to their abilities, making them more approachable. Folks with vision impairments might use the feature that everybody thinks about when talking about accessibility, a screen reader. For those with speech impairments, text-to-speech can be of invaluable help to being a part of the community and having fun with their friends in a multiplayer game. Folks with auditory impairments might rely on what we all have become addicted to, closed captions. After a long day, having to figure out inconsistent UI patterns is the last thing I want to do. And if I struggle, imagine someone with a cognitive disability having to navigate this daily. Making your UI simple goes a long way. The list that I've shown is just the tip of the iceberg. Here's a more extensive list of accessibility features, including difficulty settings, gameplay assist, sensitivity settings, scalable text, separate volume controls, skippable QTEs, and more. And this is not the end-all, be-all. Knowing all of this, I think we are better equipped to answer the question, what is accessibility? Put simply, it is leveling the playing field and making the digital technology easier to use for everybody, regardless of their abilities. Now, I'm going to level the playing field myself by inviting Karl to teach all of us what localization is about.
Thanks, Bianca. Now, when most people hear localization, they think it's just about translating text from one language to another. But true localization is about cultural fluency, not just linguistic translation. It's understanding that thumbs up icon might be offensive in some cultures, that reading patterns affect UI layout, and that's what's funny in one country might be completely lost in another. Let's take a closer look at some of these areas. Strings. This goes way beyond swapping hola for hello. We're talking UI text, dialogue that maintains character personality across languages, subtitles that sync with different speech patterns, menu items that make cultural sense, and error messages that don't sound like they were written by a robot. Regional preferences. Your players expect dates in date, month, year format in Europe, but date, month, date, year format in the US. Currency isn't just symbols, it's purchasing power and local pricing strategies and cultural norms. That's knowing when direct communication works versus when you need to be more indirect. Assets. Every image with embedded text needs recreation, not just translation. Audio files require native speakers, not just bilingual ones. Icons that seem universal often aren't. A mailbox looks completely different in Japan than in Germany. Even core gameplay might need adjustment. UI layout. German text can expand 30% longer than English. Arabic and Hebrew read right to left, flipping your entire interface. Some languages need larger fonts to remain readable. Your beautiful tight design, it needs to be flexible. Cultural adaptation. Red means look in China, but danger in most Western countries. Hand gestures in your character animations might be offensive. Even gameplay elements like gambling mechanics or showing skeletons can determine whether your game launches in certain markets. Today, we're sharing the evolution of Letterspell. Letterspell started as a demo for our screen reader support and system accessibility settings APIs and was built with UGUI. As we worked on it, we realized we had the perfect testing ground for two critical challenges that most developers either avoid or treat as afterthoughts: making games truly accessible and genuinely localized. So we made a decision. Instead of just patching features onto the existing app, we rebuilt Letterspell from the ground up using UI Toolkit. This wasn't just about modernizing the UI framework, it was about transforming our simple demo into a comprehensive case study for inclusive design. The result? A game that works seamlessly with screen readers, adapts to system accessibility settings, and speaks multiple languages authentically, and respects cultural differences. More important, it's a blueprint you can follow. In this presentation, we'll take you through our journey across two interconnected worlds: accessibility and localization. You'll see the specific decisions we made, the problems we solved, and how these two approaches work together to expand your potential player base.
Letterspell would not have been possible without the fierce dedication and unwavering willingness to get it done in time by our colleague Alexandre Zimive, who was the key to Letterspell's success.
Let's take a quick look at Letterspell and how it works. After the splash screen, the welcome screen is where every player begins their journey. It's straightforward. Enter your name and you're ready to start playing. Next, players reach the home screen where they select their preferred difficulty level. We give them two choices, easy and hard. The game screen is where the real action happens and where players will spend most of their time. Here, they see a scrambled word that they need to unscramble along with an optional clue if they need a hint. This screen also includes buttons to pause, skip to the next word, and access the options menu. The pause screen appears when players need to take a break from the game. From here, they can either resume their current game or exit entirely. The game over screen marks the end of the player's session, whether they successfully worked through all the words or chosen to skip some. Finally, there's the options screen where players can customize their experience. Here, they can adjust gameplay settings, audio preferences, and the app's visual appearance to suit their need. Now, I'll hand over to Bianca, who will show you how we made each of these screens more accessible.
Karl. Since Karl has worked so much on our localization features, I'm trying to see what language I can catch him with. All right, let me walk you through how we made letterspell more accessible. First off, we made it accessible to screen readers. But before we get into the technical details, what is a screen reader? It is a piece of tech that reads items on the screen and provides custom gestures or controls to interact with the device. They are a godsend for people with visual impairments, but they are actually used by more people than that. For example, my husband, who has ADHD, chooses to turn the screen reader on when he's welcomed by a wall of text that he doesn't have the patience to read. Some screen readers come built into the main operating systems. For example, on Android, you'll find TalkBack. On Windows, there's Narrator. And all Apple platforms include VoiceOver. Now, raise a hand if you think implementing screen reader support is easy. No point. Everybody complains about it. Games and apps made with Unity are by default a black box for screen reader, just like this slide. Screen readers cannot navigate a UI or the UI of a Unity application because for them, it is just an image on the screen. Because we want to make it easy for you to create experiences that everyone can enjoy, we added native screen reader support in the Unity runtime. In Unity 6.0, we added it for Android and iOS, and I'm happy to let you know that in Unity 6.3, we extended it to macOS and Windows. This API is part of the accessibility module, which is conveniently enabled by default in all new projects. To enable it in an existing project, you can easily find it in the built-in section of the package manager. We made the API agnostic of the UI, so you can use it with any UI framework you use, even with custom ones. Now, how useful is it for someone to be able to navigate your UI, but not be able to play your game? Gameplay also needs to be accessible. Games that make high use of UI in the gameplay benefit the most from screen reader support. Our game Letterspell is such an example. Let's try to navigate it with VoiceOver on macOS before implementing screen reader support.
VoiceOver on Letterspell. Letterspell. Window. Letterspell. Window.
As you saw, when I pressed the VoiceOver key combinations to try to navigate the UI, nothing happened. This is a good indicator that currently Letterspell is inaccessible to screen readers. Let's look into what screen readers need to navigate an application. They must receive information such as what the accessible elements are, where they are placed on the screen, what role they have, and how a user can interact with them. Let's not forget that this information also needs to be localized. I had to mention this, otherwise Karl wouldn't be too happy with me. The information that we need to send to the screen reader is grouped into what are called accessibility nodes. An accessibility node has several attributes that define that tell the screen reader how to accurately describe and interact with the visual element that the node represents. Here are some examples. The node's label should provide a short description of the visual element corresponding to the node. This will be read by the screen reader when the user navigates to the node. The node's frame defines the screen coordinates of the visual element corresponding to the node, which allows the screen reader to show its focus indicator at the correct place. The role defines the control type of the visual element. The screen reader will announce it to the user and adjust its behavior accordingly. Finally, if the node's status may change, the value or state attributes can be used to reflect its current condition. The accessibility nodes are organized in what we call the accessibility hierarchy. In Letterspell, we rebuild the hierarchy each time the screen changes. What do you think the hierarchy for the gameplay screen would look like? It is simpler than what you might expect. It mirrors the important UI elements, the clue text, the letter cards, and the game buttons, but it omits elements such as view containers because these are not necessary for screen reader navigation. In Unity, the UI hierarchy and the accessibility hierarchy operate independently from each other. So we need to make the connection and synchronization between them ourselves. This might look different depending on the UI framework you use. In Letterspell, most of the code we need is already there. However, there are a few crucial places that we need to go through and complete together. First, let's look at what we have to do to send our hierarchy to the screen reader. Here is some code from Letterspell. For now, I'm hiding the extra code that is specific to our game, and I'll walk you through the fundamentals. You'll be able to extrapolate based on that. You can create as many accessibility hierarchies as you want, but you have to assign one as the active hierarchy. This is the one that will be sent to the screen reader. In Letterspell, we build a hierarchy for the current scene in our custom method generate hierarchy. Then we activate it by assigning it to assistive support.active hierarchy. We do this each time the screen changes or the screen reader is turned on. When we build a hierarchy, we add accessibility nodes to it by calling insert node on the hierarchy to which we pass the index, the label, and the parent under which we want to insert the node. In most cases, the label is the text of the visual element corresponding to the node, while the parent and index are based on the position of the visual element in the UI hierarchy. After we add the node, we can set other properties to define its role and behavior. For Letterspell, most of these are already set in other places. With these changes, let's see if we can navigate Letterspell and play the game.
Voiceover on Letterspell. Letterspell. Window. Options. Button has keyboard focus. Play easy button. Play hard button. You are currently on a button. To click this button, press Control, Option, Space. Play easy button.
The screen reader identified our UI elements, and we managed to navigate the screen. However, I could not activate any of these buttons, which tells us that this is not the end of the story. We have made good progress, but there is still a bit left to do. The buttons don't work because the screen reader intercepts all user input. Based on this, the operating system sends us specific accessibility events representing the user's intention. Unity's accessibility APIs makes it possible to connect to these events. In our case, we have to listen for the invoked event on the accessibility nodes that represent our buttons. When a node receives this event, all we have to do is programmatically click the button corresponding to that node. Let's see this in action.
Voiceover on Letterspell. Letterspell. Window. Options. Button has keyboard focus. Play easy button. Play hard button. You are currently on a button. To click this button, press Control, Option, Space. Play letters, not daytime. Clue. The letters are now G, N, I, T, H, G, N, I, T, H. Pause the game button. Options button. Next word button. You are currently on a button. To click this button, press Control, Option, Space. A panda's favorite snack. Clue.
Great, we can activate the buttons. Now, looking at the gameplay, there are a couple more things left to do. First, after the user moves a card, we move its corresponding accessibility node, but we also have to let the screen reader know that the UI has changed and update the screen reader focus to the new position of the node. We can do this easily by calling setLayoutChanged and passing the node corresponding to the moved card. Second, while the position of the card is obvious for sighted users, it might not be as obvious for someone who cannot see the screen. We can make the screen reader tell the user where the card was moved by calling sendAnnouncement and passing the message that we want to send. Let's see if this works.
Voiceover on Letterspell. Play easy button. Play letters. What you do on sidewalks. Clue. The letters are now W, L, A, K. Double tap to L, A. Double tap to start moving. A. Moved A before L. You found the correct word. It was walk.
Amazing. There's one more thing that I want to show you. Because we know how difficult it is to keep track of all the accessibility nodes and how they are grouped in a hierarchy, we also developed the Accessibility Hierarchy Viewer. This tool allows you to see exactly what your app is sending to the screen reader without you having to build and run your app on a device. This aims to make it easy for you to debug your accessibility hierarchy right from within the Unity editor, but it does not replace testing your application with a screen reader on a real device. In Unity 6.3, we have not only extended the screen reader support to Windows and Mac, but have also added some extra functionality. Let's take a quick look at the new additions. We added more accessibility roles, now supporting container views, text fields, drop-downs, tab buttons, and scroll views. As part of a refactoring effort, we deprecated the accessibility node selected event and renamed it to invoked. We also added support for screen reader scrolling in the form of the scrolled event and the send page scrolled announcement method. And finally, we added the screen reader status override property so that we can enable the functionality of these APIs even when the status of the screen reader is unknown. As I mentioned previously, accessibility does not only mean screen reader support. That is why our accessibility module also comes with APIs for retrieving certain system accessibility settings, specifically bold text, text scaling, and closed captioning. Currently, we support this on iOS and Android. Letterspell already uses these APIs. When the user changes their bold text preference in the system settings, we receive the bold text status changed event and respond by toggling the bold style for all texts in our game. We also listen to the font scale change event, to which we respond by adjusting the font size of all our texts accordingly. All of these changes can be easily done in UI Toolkit by setting the style properties of our UI elements. En este punto, las abuelas de España no entienden nuestro juego.
Don't worry, Bianca. I'm going to make it so Spanish grandmothers can understand and play our game as well. Our first step is identifying every piece of text that players will encounter. You'd be surprised how much there actually is, even in a simple game, word game like Letterspell. Take our splash screen and welcome screen, for example. Both contain static text that needs translation, labels, buttons, and inputs. Here's something most developers miss. Even the background design matters. Right now, it displays letters from the Latin alphabet, but not all languages use these characters. A Chinese or Arabic player might wonder why their game is decorated with letters that have nothing to do with their writing system. Then there's the gameplay itself. The static UI text is just the beginning. We also need to localize the actual game content. Next, there's the options screen. It contains the most text of any screen, and some of it isn't just static, it changes dynamically. Those on-off labels need to update based on the player's current settings, which means our system needs to handle real-time text switching, not just one-time translations. The Game Over screen adds another layer of complexity. Along with its static text, it displays one piece of dynamic content that is deceptively challenging as it uses plurals. Think you completed one word versus you completed 5 words. English handles this simply, but many languages have complex plural rules that our localization system needs to account for. The first step is setting up the localization package, which isn't enabled by default. It should be. Install the localization package through the package manager, then head to your project settings. Under the localization section, add English as your base locale. This will serve as your source language that everything else gets translated from. You can add your target languages now, or leave them for later once you know which markets you're targeting. For our demonstration, we'll localize to Spanish, Japanese, and Arabic, 3 languages that showcase different localization challenges you'll encounter. Since we rebuilt our screens as UXML files during the UI Toolkit conversion, we now need to extract all the hard-coded strings from these files and migrate them to a centralized string table. This string table becomes our single source of truth for all text in-game. Once we've moved the strings over, we will add localized string bindings back to their original locations, essentially creating references that pull the correct translations based on the player's language settings. Once our strings are connected to the string table through those bindings, we've centralized all our text management. Now, any change to game text, including adding translated values, happen directly through the string table. In practice, you typically wouldn't handle translations within Unity itself. Instead, you'd export your string list and send it to a professional translator, then import their work back into your string table. This keeps the technical and linguistic work separate, which is exactly what both developers and translators prefer. We also support XLIF, a standardized format used by a lot of localizers, and Google Sheets as well, which is very popular. It's also possible to add custom exporters and importers if you have a format that's not natively supported by us. For example, a lot of people like to use JSON. To get your translations, you have several options ranging from quick and risky to thorough and reliable. AI translation tools are tempting because they're fast and cheap, but here's the problem. You have no way to verify the output is correct. Even more critical, AI lacks the context that human translators bring. It doesn't understand your game's tone, your target audience, or cultural nuances that could make or break player engagement. Translation software. Online tools step up from pure AI, but still miss crucial context. They might get individual words right, but they don't capture the personality of your characters or ensure your humor translates appropriately. Not all translations are direct word to word, but sometimes require a translator to be able to convert a joke that maybe doesn't work in one language to another. Professional translators, fluent in your target languages, remain the gold standard. They understand not just the words, but the culture, the gaming conventions, and how to adopt your content so it feels native to speakers. Context is everything in game localization. Without it, even the best translators can turn your witty dialogue into confusing nonsense, or accidentally make your friendly NPC sound threatening to players in certain cultures. Let's have a look at some of those areas of context. Purpose. Purpose matters. Is your text instructional, press X to jump, or narrative? Each requires completely different translation approaches. Know your audience. A children's puzzle game uses different language than a complex strategy title. Age, gaming experience, and cultural background all shape how your message should be delivered. Constraints. As I said earlier, German text can expand to 30% longer than English. This means you should be careful that your UI is able to either properly adapt or ensure with your translators that the resulting text stays within a certain range. Register and tone can make or break immersion. Your casual, friendly tutorial shouldn't sound like a formal business letter in Spanish, and your dramatic villain shouldn't come across as politely asking for directions. Cultural references are translation minefields. Break a leg means good luck in English, but translating it literally elsewhere might confuse players, or worse, sound threatening. Even the understanding between UK and US may not be fully equal. Cultural differences matter even when it's the same language. Regional variants, or variations, matter even within the same language. Pants means something very different to UK players versus US players. Multiply this across dozens of languages and the complexity explodes. Visual context shapes everything. Text that works perfectly in a menu might be incomprehensible when squeezed into subtitle space or displayed over gameplay. I never get this word. Ambiguity requires human judgment. When your script says bank, does it mean the financial institution or the river's edge? AI can't know, but your players will notice if you get it wrong. Consistency. Terminology should be consistent. You don't want to confuse users by changing the way you refer to certain game elements and mechanics. For example, using the term health for a player should be consistent when translated and should not be mixed between different versions, such as vitality. All of these factors combine to determine not just what your translations say, but how it makes your players feel about the game. Let's see how we apply these principles to our actual screens, starting with the splash screen. Rule number 1, avoid embedding text directly into textures when possible. Text in images is a localization nightmare. You need separate artwork for every language which multiplies your asset management complexity and file sizes. For our splash screen, we initially considered creating different texture versions for each language. While this works, it's expensive and hard to maintain. Instead, we found a better approach. We decided to create a more universal splash screen that was not language specific. We decided against localizing the game title. There's no hard rule for this. Some choose to localize their titles. However, we decided to treat the game name as more of a brand and keep it the same in all languages. We removed the subtitle and turned it into a separate label, which can then be localized. The background was made more universal by adding glyphs from multiple languages, so it wasn't just Latin alphabet. Another texture we tackled was the correct message that appears during gameplay. We realized there was no technical reason for this to be a texture at all. It was probably a design decision made during development to be quick and dirty. So we rebuilt it using visual elements instead, essentially converting static artwork into a dynamic text-based UI component. So that was much easier then to translate. Here, we chose to create localized versions with appropriate glyphs for each language. So we did break our rule a little bit. While this goes against our avoid text and textures rule, the visual impact was worth it. Seeing familiar characters from their own writing system helps players feel immediately welcomed into the game world. The same localization system that handles our strings can also manage our audio clips. Different voice actors for different languages, region-specific sound effects, even culturally appropriate background music. It all flows through the same pipeline we built for text. The game over text is an example of dynamic text in the game. It was also using plurals, although they were not correct at the time. A player who found exactly one word would see "you found 1 word out of 6, which any English speaker immediately recognizes as wrong. It should be word, not words, when the count is 1. Fortunately, the localization package contains support for handling plurals and more through its smart string system. First, let's fix our English grammar using the plural formatter. The syntax is straightforward. The first argument defines the singular form, and the second defines the plural form. So instead of hard-coding words, we let the system choose between word and words based on the count. Notice we're using a named placeholder called total words here, instead of a numeric index like you would with string.format. This might seem like a small detail, but it's huge for translators. When they see total words, they immediately understand what the number represents. When they see a numeric index, such as 0 from string.format, they have to guess, and wrong guesses lead to broken translations. These placeholders can work in 2 ways: as local arguments passed in when you display the text, like string.format, or as persistent variables that you can update independently throughout the game. This flexibility becomes essential when you're managing complex UI text across multiple languages. Let's see how this looks once we translate the smart strings. So here you can see the English. We're using the named placeholder as we had before, and we have the singular, which is word, and then words. And the open and close bracket means to use the current value. So what it'll do is the game is over, you found current value, and then it will pick either words or word. Next, we've got Spanish. Now, Spanish has similar plural rules to English, so you only have 2 versions again. So we have palabra for the singular, palabras for the plural, and we're using the same named placeholder. For Japanese, the word doesn't actually change based on the number, so we don't need to use the plural formatter. We can just put the named placeholder directly in. But the string has a similar format, so a translator who understands the smart string system can then pick how to make that string. They don't have to use the plural formatter for every language. And for Arabic, we had this translated, so I can't really talk much more about it because I don't understand Arabic, but it is correct. Finally, let's look at the gameplay. Each round consists of a word and an optional clue. Easy questions all had answers with 4 letters or less, but after translation, that can change. Some of these questions are now more suitable for the hard category. So we can see hat, when translated, becomes a much longer word, sombrero. We won't be able to do direct translation for each of these. We will need to adjust the gameplay so that after translation, they are in suitable categories. We will need to localize the gameplay. The gameplay is controlled by a word database. This is a scriptable object that is created with an imported JSON file. The localization package comes with built-in tools to localize any Unity asset type. We can create a localized version of the word database for each language. As you can see here, each one now is a separate database, and then it'll pick the right version based on the language for the gameplay at runtime. This lets us ensure that the difficulty of each question is appropriate. Finally, I want to mention some of the new features that have been released in Unity 6.0. Right-to-left support has finally arrived for UI Toolkit as part of Unity 6.0. More specifically, we now fully support bidirectional text, all of the OpenType font features, and Apple Advanced Typography specifications. This enables support for complex scripts and languages such as Indic, Devanagari, Malayalam, Middle Eastern scripts, Arabic, Urdu, and complex emoji sequences. Yeah, it's about time, isn't it? This latest text system is based on top of industry standards, open source libraries like Halfbuzz and ICU. These are well-established and long-living projects that the rest of the industry has been using and contributing to for many years. These features come as part of the advanced text generator. To use them in Unity 6, you'll need to enable the advanced text generator in the project settings. It's not enabled by default. Right-to-left support can then be enabled per text element for a smooth and gradual transition. The UXML attribute language direction can now be used to set the directionality of a paragraph. Ahora dejo a Bianca.
Dhanyavad, Karl. Letterspell is available on GitHub under Unity Technologies A11Y public sample. I invite all of you to clone the repo and play around with these features, as well as study how we implemented them with both UGUI and UI Toolkit. When you break Letterspell, if you want to understand what broke or why things are how they are, you can always visit our documentation to help you better understand what is going on. And when you really get stuck, you can always come to Unity discussions, put a question in, and we will definitely be glad to be part of your journey by helping you. From my experience, I can definitely say that the community is also there to help. Just be sure to use the tags accessibility features or localization, as we have so many features that it's easy for us to miss questions. You would be surprised how creative some of you are when you don't know what tag to use. Here is what I hope we have learned today. People with disabilities do play video games. Accessibility does not affect only vision. With Unity 6, it is now easier than ever to support native screen readers. If you make your digital experiences more accessible, you'll be able to expand your audience by tapping into a market that you previously did not have access to.
And when it comes to localization, it allows games to reach a global audience, but accurate and culturally appropriate translations require proper context. And finally, Unity 6 now supports right-to-left languages with the advanced text generator.
After all that we've showed you, I think some of you in the crowd are already pumped to make your digital experiences more accessible. Now you have a very good reason to do so. But just in case you might feel like you need another reason to think of accessibility, I'll just point you to a couple of letter groupings and sometimes numbers that I'll ask you to get acquainted to by yourselves, as I'm not a lawyer. Just in case you're wondering what these are some of the biggest laws and standards governing accessibility around the world. From what I understand, they may have a fair bit of implications. Before we move to our Q&A segment, please take the time to help us shape accessibility tooling in Unity by scanning this QR code and filling out our very short survey. Now, you've heard enough from Karl and me. we've reached the Q&A section, and we would love to hear from you.